Okay, this will be a quick video to help support you and provide you a little more practice with lessons 5.9 and 5.10. I'm going to cover volume of cylinders and spheres, and we're going to work on problem solving by keeping pi instead of typing it in your calculator as either pi or 3.14, but instead keeping it as pi. Okay, we're going to start with a problem where you have to compare the volume of a cylinder to the volume of a cone and figure out which has the greater volume. So use the diagram below to determine which has the greater volume, the cone or the cylinder. So the first thing I'm going to do is write out the formula for each one. So the volume of a cone is base times height. And remember, capital B means the area of the base. So that's going to be a circle. And the area of the base is going to be the area of the circle, which is pi r squared. So r is 4. So r squared is 16. So that's going to be 16 pi. Now my height is 6. So I'm going to multiply that by 6. So when I multiply it by the height, I get 96 pi centimeters cubed. And notice I kept this problem in terms of pi. I did not punch in the pi button on my calculator, and I also did not use 3.14 because that is an estimated answer. It's rounded. If you keep pi as the symbol pi, it's the most accurate. I'm going to do the same thing with the cone. The volume of a cone is base times height, but then divided by 3 because a cone is 1/3 the volume of a cylinder. So my base is also a circle, pi r squared. R is 6, so r squared is 36. So my base is 36 pi. And then I'm going to multiply that by the height. And I get 288 pi. Then the last step is right here. I need to divide that by 3. And that equals 96 pi centimeters cubed. So my two volumes are equal. So none is greater. They are equal. So the volumes are equal. The next problem I'm going to do is a target problem. So I have to remember that the area of a circle, again, is pi r squared. So I'm going to look at the smaller circle first. The radius is 7, so radius squared is 49. So the volume, not the volume, the area, is going to be 49 pi. And that's of the small circle. That is red. Now I'm going to do the larger circle. And now my radius is going to be 7 plus 3 is 10. So my radius is 10. Radius squared is 100. So the area of the larger circle is 100 pi. Now if I was asked to find the area of the outer ring that I put yellow lines in, I would want to subtract 49 pi from 100 pi. And I get 51 pi. So the area of the outer ring is 51 pi. Notice you treat pi just like a variable, and it doesn't go away unless you're dividing pi by pi, and it would cancel out. And I'll show you an example of that in this video. Okay, now you have the same scenario, only instead of knowing a number for the inner circle radius, you have a variable x. It's unknown. So this is from the previous problem, but we'll use it to figure out how to write a function. And as a reminder, a function is just like a formula. So the first thing I want to do is think, how did I get the 100 pi? So I know that it was something to do with pi r squared. So pi is going to stay the same, and my r was x plus 4 because it's the larger circle. And then if I want to square that amount, x plus 4, and again that's x plus 4, that's adding the inner circle's radius to the outer ring, which is given. It's 4, the width of the outer ring. So if I want to square that, I have to put it in parentheses because it's one number. We just don't know what the x part is. So I have x plus 4 squared times pi. So that is how I got my 100 pi. Now my 49 pi is the inner circle, and that is also pi r squared. Pi is going to stay the same, but in this case, my r is x. So I don't need to put that in parentheses because it's just one value. So I have pi x squared. And now I'm going to take these two values and subtract the bottom one from the top one. So my final function looks like this. Pi, I'm going to make more room down here. This is this first part, pi times x plus 4 squared minus, now I'm going to do this second part, pi x squared, and that's going to equal the area of the outer ring. So if you look at a problem using numbers, it helps you to figure out how to get the different parts of the function. Okay, the last problem we're going to do is a little bit of a trickier one involving the volume of a cone, only you're given the total volume and you have to work backwards to find the height of the cone. So the first thing you want to think of is the formula for the volume of a cone, and it's the area of the base times height divided by 3. And so that amount is going to equal 48 pi. And you're going to fill in everything you know. So I rewrote my formula, and base is pi r squared. It's the area of the base. And we are given r, which is 4, so r squared is 16. So we can figure out the base is pi 16 pi is our base. So now I can take that and plug it in there. So I say 16 pi times my height, which I actually labeled as x, divided by 3 is the given volume, 48 pi. Now what I want to do now is solve for x. So the first thing I want to do is multiply each side by 3. That cancels out the 3, and then I no longer have a fraction. So I have 16 pi times x is 144 pi, which is 48 times 3 times pi. And now I'm solving for x, so I want to get rid of the 16 pi. So it's being multiplied, so I do the opposite, which is divide by 16 pi. Now in this case, pi divided by pi is 1, so the pi's cancel out. And this cancels out, so you have x equals 144 divided by 16, which is 9. So my height equals 9 centimeters. Okay, let your teacher know if you have any questions about how to do any of the skills covered in this video. Enjoy!